What if every choice you've ever made, every hesitation, every word you didn't say, actually created a new universe? Not in theory, not in science fiction, but in the cold, unyielding math of quantum mechanics. A girl who wrote through genocide, a priest who saw the birth of the cosmos before anyone believed in it, an industrialist who reimagined what a nation could afford. I've told their stories, the unlikely timelines that became real. But what if there were others? One where Anne Frank's diary was never found, where Georges Lemaitre's theory of the universe stayed forgotten, where Ratan Tata's nanocar never made it off paper. In science fiction, from Loki to Dark, from the MCU's multiverse to quantum theories in labs, we chase a single idea. What if every choice branches a new world? What if you're living in just one version, out of infinite ones? This is the story of the man who first wrote it down and disappeared into its silence. Welcome to Echo Echo. And this is the forgotten birth of the multiverse. To understand Hugh Everett's rebellion, you first need to know what he was rebelling against. By the mid-20th century, quantum mechanics was well established, but not well understood. Physicists had unlocked strange behaviors, particles that behaved like waves, electrons existing in multiple places at once, measurements that seemed to collapse reality into a single outcome. But no one could agree on what it meant. The dominant explanation, led by Niels Bohr's Copenhagen school, insisted particles exist in probability until observed. Reality doesn't decide what it is until you check. A particle isn't here or there. It's both, until you peek. Then suddenly, it picks one. This created a terrifying riddle. Who decides what counts as observation? Why should the universe care if you open a box? Schrödinger dramatized this with his famous thought experiment. A cat sealed in a box, both dead and alive until someone opens it. It was absurd, but it wasn't a joke. It was a warning that our interpretation made no sense. Here enter Hugh Everett, not a celebrity physicist or philosopher, just a young man from the Naval Academy who studied physics at Princeton. Quiet, mathematically gifted, and utterly unafraid to question authority. While students accepted Copenhagen with reverence, Everett asked, "What if we stop assuming wave functions collapse? What if every possible outcome is real, but each exists in a separate, non-interacting universe?" It wasn't just bold, it was heresy. Everett proposed that measurement doesn't reduce the universe to one reality. Instead, it splits the universe into multiple, equally real branches, each containing a different outcome. One where the particle goes left, another where it goes right. One where the cat lives, another where it dies, and one where you stopped watching this video. But in this branch, you didn't. In 1957, Everett submitted his PhD thesis titled The Theory of the Universal Wave Function. It was concise, mathematically sound, and quietly explosive. His advisor, John Archibald Wheeler, was intrigued but nervous. He knew this would spark war with Niels Bohr. Still, he accompanied Everett to Copenhagen, where the young theorist would present his work. The meeting did not go well. Bohr dismissed Everett's idea almost immediately. He didn't want a new interpretation. He wanted loyalty to the old one. Everett returned disillusioned. His thesis, barely published, received no attention. No jobs, no invitations. He had written the most radical idea in physics since Einstein, and no one cared. So he walked away. At 26, Hugh Everett III left academia and never returned. He took a job in defense analysis, spending decades on military logistics and game theory. The man who dreamed of infinite universes spent his days modeling nuclear war. He never again published in quantum mechanics, but his idea did not vanish. It waited like a message in a bottle, floating across decades until the tide changed. Years passed. Everett grew older, quieter, more withdrawn. His groundbreaking thesis gathered dust in obscure archives. But not everyone forgot. Physicist Bryce DeWitt revisited Everett's work in the 1970s. He saw its beauty, its symmetry, and gave it a name that would change everything: the many worlds interpretation. Suddenly, Everett's lonely vision had language and believers. Nobel Prize winners like Richard Feynman and Murray Gell-Mann explored its logic. Philosophers debated its implications. Writers and directors turned it into story. The multiverse wasn't just science anymore, it was culture. And at the center was a man who never saw it happen. Everett died in 1982 at age 51 from heart failure, believing his work was a failure. But it wasn't. Everett had a son, Mark. They barely spoke. Hugh was distant, cold, more equations than emotions. Mark became a musician, lead singer of the band Eels. Years after his father's death, Mark opened dusty papers. Old equations, marginal notes, and a theory that had become legendary. He discovered his unreachable father had changed physics. It's amazing someone could write something so important, yet feel so forgotten, Mark said. He made a BBC documentary, Parallel Worlds, Parallel Lives. A journey into the absence left by a man who believed in infinite realities but couldn't fully exist in this one. Few realize Hugh Everett didn't vanish from science. He applied his logic elsewhere, to war. Working inside the Pentagon's Weapons Systems Evaluation Group, he shifted from wave functions to warheads. At the Cold War's height, he designed strategic models for nuclear conflict. This wasn't fiction. It was logistics, probability, scenario analysis. Everett built decision trees for apocalyptic chess, predicting how nations might launch nukes and behave after surviving them. It was many worlds logic applied to geopolitics. Each branch was a possible war. Each calculation, a different endgame. He evaluated shelter strategies, decapitation strikes, retaliation probabilities under mutually assured destruction models. His peers found him brilliant but existentially distant. As one colleague said, Hugh thought like no one else, but you couldn't tell if he was thinking about the problem or the version in 10 other worlds. While Everett strategized nuclear scenarios, quantum physics evolved rapidly. The core problem remained. No one could explain why observation collapses probability into one outcome. Some asked, what if it doesn't collapse at all? Instead of reintroducing Everett's thesis directly, quantum decoherence emerged. It proposed that when quantum systems interact with environment, all outcomes remain, but become effectively invisible to one another. Branching still happens, but we only perceive one branch because others become inaccessible. This wasn't science fiction. It was physics grounded in thermodynamics and information theory. Many worlds suddenly had a bridge. Mathematical mechanism without philosophical mysticism. By the 1990s, many worlds was no longer just thought experiment, but serious contender for quantum theory's foundation. David Deutsch and Sean Carroll advocated for Everett's vision, not as metaphor, but as the most logical explanation of quantum behavior. No observers needed, no metaphysical collapse, just a universe doing what math says, splitting. As Everett's theory gained scientific attention, fiction began echoing many worlds. Not quoting equations, but mirroring the logic, branching timelines, alternate selves, coexisting destinies. Jorge Luis Borges had accidentally predicted this in The Garden of Forking Paths, a book where all possible choices played out in parallel. Then came films, Back to the Future 2, Groundhog Day, Donnie Darko, Dark, Loki, Everything Everywhere All at Once. Each played with the same idea. Reality is not fixed. Versions of you, different, broken, better, worse, might all exist beyond memory's edge. They didn't cite Everett, but spoke his language. Why did multiverse explode in fiction first? Because it solved storytellers' centuries-old struggle, how to explore character completely. Traditional stories end with final, irreversible decisions. Multiverse stories show every version of that decision, the hero who runs, the villain who chooses mercy. Multiverse fiction is character X-ray, revealing not who someone is, but who they could have been. This was closer to Everett's insight than many physics textbooks. Existence itself branches continuously. quietly, without permission. As our understanding of quantum theory deepened, a new frontier emerged: quantum computing. Unlike traditional binary computers, quantum computers use qubits existing in superpositions, both on and off until measured. David Deutsch, quantum computing pioneer, explicitly credited many worlds as the most natural framework for understanding qubits. When quantum computers process information, they don't merely simulate outcomes. They perform computations across parallel universes, each branch contributing to results. Suddenly, Everett's idea wasn't philosophical anymore. It was operational. Quantum computing offered a glimpse into the multiverse's machinery. While quantum theorists explored the microscopic, cosmologists were facing a different mystery. Why is the universe the way it is? Tiny changes in the fundamental constants, like the strength of gravity or the charge of the electron, would make stars, atoms, and life itself impossible. This precision seemed too lucky to be random. Some called it the fine-tuning problem. Others, the anthropic puzzle. Many worlds offered a radical answer. If there are infinite universes, each with slightly different physical laws, then it's not surprising that we live in the one that supports life. Because only in such a universe could we exist to ask the question. This wasn't proof, it was logic, and it reshaped how physicists viewed the origin of everything. Not as a unique event, but as one realization among endless branches. In this view, the Big Bang wasn't a beginning, it was a fork. By the time many worlds entered mainstream physics, its creator was gone. His name rarely appeared in new papers. The multiverse was rising without him, a theory so powerful it no longer needed its creator. In countless branches of reality, we might be entirely different. In some, more celebrated, in others, more forgotten. But that is the truth of infinite possibility. Someone has to live in the timeline where choices go unmade, words go unsaid, and dreams remain unfinished. And in every other branch where you exist, you're still asking the same question that echoes through eternity. What if this isn't the only world? The answer whispers across infinite realities. It isn't. This is Echo, and these are the infinite lives we never lived.